Honors Algebra 2, here are the rest of the notes from day 3 when we were talking about ellipses. So first off, we took our general equation of a conic, we completed the square, and now it's in a form of an ellipse. So we're going to go through finding the information and graphing. First thing we want to notice is the center is going to be the opposite of what is in parentheses, so positive 2 and negative 5. I'm going to go ahead and graph it as we talk about it. 1, 2, 3, 4. So there's my center. Then, directly below the x squared term, you are going to have rx squared. Think of the basic formula of a ellipse. So really, this is saying that square root of 9 is the distance I go from the center in the x direction, which means I'm going to go 3 to the right and 3 to the left. Then, underneath the y squared term, this is ry squared. So 4 is really equal to ry squared, which means ry is 2. So 2 in the y direction, up and down. And just like that, you have your ellipse. So with that, we're going to answer the information below. First thing is the major vertices. So the major vertices fall on the major axes. So first off, the major axis is going to be this horizontal line because it's longer than the x equals 2 line. So major vertices then would be here and here, which means major vertices are -1, -5, and 1, 2, 3, 4, 5, -5. The minor vertices fall on the minor axes, so those would be those 2 points, which is 2, -3, and 2, -7. I'm going to leave foci for just a moment. Major axes equation. So it's the equation of the longer axes. So the equation of that would be y equals -5. Minor axes, x equals 2. Again, that comes directly from the center. The length we think of as major to major. So this entire length is 6 for the major. For the minor, it is 4. Now the foci, we have an equation for the foci, and it has to be from above, whichever is positive. So looking at this case, we have to see is rx greater or ry greater? Well, in this case, the rx is 3, ry is 2, so rx is bigger. So the formula we're going to use is rx squared minus ry squared. These can be found from the bottom of our equation or in our graph. So when we do the math, it should be 3 squared minus that distance squared. So the foci squared is 5. Square root. Because it is a distance, we're going to make sure we always keep the positive, but it means it's about 2.24 from the center. Okay, from the center on the major vertices, on the major axes, sorry. So it's about 2.24, so about here, -2 point right there. Those would be our foci. Okay, they're 2.24 from the center on the major axes. So the actual the actual point is about -0.24, comma, -5, and 4.24, comma, -5. And really the foci are going to be on the major axes and inside the ellipse. Hopefully that clears up example. And now we'll do another one. So here, this is the general form of a conic. So we first have to complete the square in order for it to look like an ellipse equation. So a little review here. Put your x terms together. Put your y terms together and leave some space. Notice it's an inequality this time. And move over your constant term. When you're ready to complete the square, make sure you GCF the first term because you have to have the a value of 1. And now we complete the square. The formula is b divided by 2 squared. Take your b value, divide it by 2, square it, and make sure you don't forget that factor in front. So really on the left side, I added a 25. B value divided by 2, square it. Don't forget the 9 in front, so really add a 36. If you did it right, you can factor that to a nice binomial. Still keep my inequality. The final step is that the right side has to be 1, which means I need to divide each term by 225. So x plus 1 squared over 9, y minus 2 squared over 25, and it's less than 1. This looks like the general equation of an ellipse. And now we're going to graph and add some information. So center, pretty straightforward, is the opposite. So negative 1, 2. So left 1 up 2. The distance, the 9, which falls under the x term, says that is rx squared. So that means in the x direction, I'm going out 3 units. Oops, maybe I should actually go 3 units. Negative 1 up 2, 1, 2, 3, 1, 2, 3. Okay. Underneath the y, this is ry squared, which is telling me that the square root of 25 is 5. I go 5 in the y direction. 1, 2, 3, 4. And there's my ellipse. One thing that's different in this problem is that it is a less than symbol, which means it is a dashed line. So as I create my ellipse, make sure you have a dashed line, and we have to add our shading. You can add it right now if you want. The shading, we can test a point. I say test the center because this point goes away, because that's be 0. This would be 0. So when you test, is 0 less than 1? Yes, it is. So you know you'll be shading inside. And whenever you decide to shade is up to you. Now we'll start filling in the information. Based on our picture, we know the major axis is going to be this one right here because it's longer. So the major vertices fall on the edges here and here. Major vertices then are negative 1, 7, and negative 1, negative 3. The minor vertices fall on the smaller axes. So those will be negative 4, 2, and 2, 2. Again, I'm going to leave the foci to the end. The major axis equation, so the equation of this line, because it's longer, is x equals negative 1. The minor axis, it's the shorter one, y equals 2, and that comes directly from my center point. The length is from vertice to vertice, so this length is going to be 10, and this length will be 6 from left to right. Last but not least is the foci. We need to figure out the equation that will make it positive. So f squared, since the y value is bigger, we're going to do ry squared minus rx squared. If you happen to choose the wrong order and you got a negative, just switch it. So let's plug in. The distance in the y direction is 5. The distance in the x direction is 3. Again, that's from here and here as well as our picture. So we have 25 minus 9, so we get 16. Oh, that's nice. Since it is a distance, we're only going to look at the positive. So it's 4 units from the center. Now it's 4 units from the center on the major axes. So from the center, go up in this case, because that's the major, and go down, because that is the major axes. Coordinate points then, -1, 6, and -1, -2. And this one's a little bit different because we had the shading and the dashed line around. Okay, last one. Kind of looks like the nicest one, so let's see what's a little different about it. First thing, this is a general conic. We need to make it an ellipse, which means we have to have it equal to 1. So divide each term by 48. X squared over 4, y squared over 48, and now we have the equation of an ellipse. Because there's no value being added or subtracted here, that means the center is just 0, 0. That's really nice. We haven't seen one like that. So I'm at 0, 0. There's my center. Rx squared is 4, which means I go in the x direction, 2 and 2. Now, the y, ry squared is 48. That one's not as nice as the ones we've seen previously. So let's take a moment and look at that. Ry squared equals 48. So I'm going to take the square root. Ry equals the square root of 48. If I simplify that, I get 4 root 3, which is about 6.93. So in the y direction, oh, sorry, I don't know why my point erased here. In my y direction, I'm going to go up 6.93. 6.93, 4, 5, 6.93. And it's just an equation, so I know that this is my ellipse. Hopefully it's clear that the major axis is the longer one, so it's x equals 0. And maybe we start there. X equals 0. Minor would be y equals 0, because that's the horizontal. The length of the minor of the smaller is 2 to the right, 2 to the left, so 4 total. Oops, sorry about that. The major axis length is from 6.93 to -6.93. So that distance in total, we can even write it up here, is 2 of my root 48s. In other words, 2 of my 4 root 3s. In other words, 8 root 3, which is about 13.85. So that is the distance of our major axes. Major vertices, not too bad because I'm starting at 0, 0. But the major vertices are going to be here and here. So how you write it, I think the easiest way is 0 plus or minus 4 root 3. We don't want to deal with those decimals if we don't have to. And then the minor is -2, 0, and 2, 0. Last part is our foci. So we look at our equation. We have to figure out which distance is bigger. So that's ry squared minus rx squared. Plugging in ry, that distance is root 48. Rx is 2. So really we have 48 minus 4. So 44. We're looking at the positive distance. So it's about 2 root 11. And that is about 6.63. from the center. Cannot stress that enough. It's on the center, on the major axes. So we're going to go up 1, 2, 3, 4, 5. Oops, sorry. Don't want to put those dots. 1, 2, 3, 4, 5, 6.3. It's a really, really close. And really, really close. Again, inside of our ellipse. So the equation of it, you can write 0, comma, plus or minus 2 root 11 if you want. 0, comma, plus or minus 6.63. All of this is because it's centered at 0, 0. So that's a very nice one that it happens to be the same answer because we're at the origin. This is our intro to ellipses. Feel free to attempt day 3 homework, look it over. We'll have time in class for questions. Have a great night.